Quick pop quiz for the non-GSWA people in the room. Who has heard of our Mineral System Atlas? Few people, okay, great. Let's change that for the rest of you. What I'm going to do today, I'm going to cut the talk into 3 separate parts. What is our Mineral System Atlas? I'm going to introduce a bit about our intrusion-hosted nickel system and how we put that into our atlas, and then a bit about the future work that our team is doing. So before I get into the nitty-gritty, I wanted to introduce this lovely bunch of people. We've got Paul, Warren and Trevor, who have been either current or past managers of this team and very much shaped this project. And the rest of us, the other 4 of us on screen, are current members of the team that are currently or have previously worked on this project. There's obviously lots of other people who have contributed here as well. So what is our Mineral System Atlas? So we were given the task to create a mineral system atlas for key commodities within Western Australia. And why did we want to do that? We're the Geological Survey. We want to help understand the geology of WA, but more specifically, we want to help understand our mineral systems that we have. We want to summarise the knowledge and the data that we have related to mineral systems. And we also want to keep providing the pre-competitive data that we have and continue to provide it to you guys, our stakeholders. So what have we built? We've built another pre-competitive data system for you guys to go and use, but it's more applicable to mineral exploration. So if anyone's familiar with our GeoView database, the GIS component of it anyway is an exact carbon copy of it, but where GeoView is very general, our atlas is very tailored and very specific to mineral exploration and what we think you guys would find useful to go out and find deposits. So it's a map of proxies of essential metallogenic processes defined by mineral system analysis and by querying primary GS science data. So at the moment, just GSWA databases. So we have 3 main components that we think, or that make up our Mineral System Atlas. We have our GIS platform, like I said, our GeoView component. We have our MSA, or our Mineral System Atlas Guide, which I'll talk about a little bit later, and everything you can go and download from DASC, our Data and Download Center. So these 3 components make up our Mineral System Atlas. As it is today, we've got 7 systems in there. I'll talk about our intrusion-hosted nickel, a couple of other ones, obviously very relevant to you guys out here in the Eastern Goldfields. We're always looking to expand this, obviously. We are sort of looking for where do we want to go next. So if anyone's got any ideas, please come and chat to me afterwards. But this is where we're currently at. When I say the atlas, I'm mainly talking about the GIS component. So it's evolving, it's interactive, and it is tailored layers specific to mineral deposits and mineral exploration. So we use primary GSWA data, we query that, and then you guys can go and compile a combination of whatever layers that you think might be useful, and then you can also export these layers and you can go and use them in your own projects and basically do whatever you'd like to them. So we have a different range of different data sources that we have in our atlas. We've got structural data, geochem data, lithology data. So some examples on screen. Where is the mouse? So structural data, here we have our major crustal boundaries. Here we've got geochem points, but these are specifically geochem points that have been taken in granitic rocks. And here we have some lithology data. So these are where we've mapped mafic intrusions, dark green being where the intrusions are dominant, and green, light green being where they're minor. So you might find them, but they're not a major part of that mapped polygon. We've also got other data sets like drill hole data, field observations, and Mindex. So this one here, we have our harmonized drill hole data. So this is showing maximum nickel grade, as you'd expect. Goldfields lights up, Musgraves, Kimberley, all the usual suspects light up. In the middle, we have our field observations. So this is where one of our GSWA geoscientists have observed in the field indicator minerals that might be useful to go and explore for manganese deposits. And then we've got Mindex data over here. So this is showing lithium mineralization sites, mine all the way down to occurrence. As I said, you can go and download all of this, so just look for the Mineral System Atlas folder in Dask, and you can go and use that as you please. We've also got our Mineral System Atlas guide, and I see this part more exciting and probably maybe more important than the actual layers themselves. So it is just a website. Go on there and it gives you detailed information about your mineral deposits, or your deposit models, your mineralization types, and the critical ore forming processes. So for intrusion-hosted nickel over here, this is what we call the landing page. So if you just click on it, it'll bring you here. It'll tell you a little bit why these deposits are important in WA, a bit about the mineralization processes. It's got diagrams on there. It's got links here. You can go straight to download the data, straight to the GIS layers from here. But what we've also got, and we very much see this as an educational tool as well, it's got recommended reading. So if you're completely new to a deposit type, you can go on here, see what papers or resources that we found particularly useful to put all this work together, and you can go and have a look at yourself. So yeah, we think it's quite educational as well. The guide also explains the how and the why we derived certain layers and how everything was created. So this is an example of one of the layers in our pegmatite system. What is this layer? The legend, where we've actually taken the data from, any filters that we've used and applied to that data, and then what we call our model logic and recipe. So this is basically the query that we have plugged into ArcGIS and the model builder, so you can see exactly how we've done it. And if you really wanted to, so if you've got your own data, similar, you can copy and paste this query and you can go and apply it to your own data. Or if we've used particular cutoffs or ranges, say for geochem, and you go, no, that's rubbish, I want to use my own, you can copy paste that, download our data and go and change it as you want and just play around with everything. So hopefully we all now know what the Mineral System Atlas is. I'm going to talk a little bit now about the intrusion-hosted nickel system in it. So if we go right back to the start, how do we actually decide what layers we're going to put into the Mineral System Atlas? We use a mineral system approach. So fairly, I guess everyone knows the mineral system is all geological factors that control the generation, preservation of a mineral deposit, and you need 4 critical processes for all this to happen. You need a source, you need the pathway, you need a trap, and then you need to preserve it all. So for the intrusion-hosted nickel, we've identified the following as the critical ingredients or the critical processes. So we need a source of the metals. This is our mafic, ultramafic magmas. How do we get these mafic, ultramafic magmas up into the crust? That's via lithospheric faults, ancient cratonic blocks, and dike sill complexes. We've then identified 3 different trap components. So we need to sulfur saturate our previously sulfur undersaturated magmas. We need to sequester our metals from our silicate melts into our sulfide melts, and then we need to concentrate these sulfides, hopefully in a nice convenient place so we can go and dig it out of the ground. Then we also need, if there's any, take into account any modification that's happened, but also preservation as well. So what we end up with is what we call our mineral system tree. So each of for the source, pathway, trap, and modification, we come up with this thing. So it's gigantic. This is why I've only put the source up there at the moment. But what it aims to do is it aims to take you through the critical process and step by step down to how we get to, down the green here, our mappable proxies, the maps that we think will be helpful for you guys. So for the source, what is the critical process? It's mafic, ultramafic magmas. What's the constituent process? So the process that controls the critical process. We need large volumes of high flux hot magmas. How would we go about targeting large volumes of high flux hot magmas? And then eventually down here in the green, this is the layers that you will see in the atlas. So the blue ones here that are highlighted are ones that are currently in there. The black ones, I guess this is very much a wish list. So the black ones we haven't done yet either. We potentially don't have the data, maybe we don't have enough data, maybe we don't know how to query the data that we have. So this is all a work in progress, but hopefully it also gives you guys some ideas. So if you guys have that data and think that it might be useful, you can go and make these maps yourself. And we do recognize that There is many ways that we could have gone about this and made this in particular, but what we wanted to do was make something that was really robust, something that was transparent, and something that is hopefully easy to follow. So you might go, why on earth do we need an FEO versus MGO map? Oh, okay, dunk, dunk, dunk. Yep, they're trying to look for the source. So here's some examples of some very simplified maps that we can make. So here we've got field observations coloured up by different rock types, and this is again everywhere that one of our geos has gone out into the field and might have indicated that they've seen olivine or pyroxene or so indicator minerals. In the middle here, we recognise that cumulates are very important for these particular systems. So we've got cumulates here based from our geochem data, again, coloured by different rock types. And then we've got some sulphur points over here as well. If you really wanted to just go nuts, you can. So you can just layer, 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 and hopefully start seeing some patterns or some things that are interesting. So over here, we've got mafic intrusion lithology overlined by, in the green, field observation. So anywhere where someone's seen a sulfidic sedimentary rock, which is important for the trap. We then, in the grey dots here, magnesium more than 32 weight %, which we think would represent a cumulate, and then magnesium number, so the red dots being quite high magnesium number. And then over here, again, lithology overlain by, in the red, field observations where someone spotted a cumulate, purple where someone spotted pentlandite, and in the yellow where someone spotted nickel copper sulfide minerals. And you can, it's not just restricted to this particular system, so if for some reason you're looking for intrusive hosted nickel, but you think that there might be a layer that's relevant from manganese for whatever reason, you can just put it all on. With all this, we aim to put out a GSWA record, for everything that we do to help, again, just try and document what we've done and be really transparent. So the future, where do we see this going? We want to integrate more databases. A big one for us is our geochron, so we want to try and start doing that. That one's a little bit more trickier than the stuff we've done previously, so that's on the list. We'd also like to start doing more field database queries and also looking at external data sets as well. And as I said, just making and adding more systems to the Mineral System Atlas. So if anyone has any ideas, please come and see me. What we're also starting to do is prospectivity analysis and producing actual prospectivity maps. So we're looking at doing the pegmatite-hosted lithium, or we've done the pegmatite-hosted lithium, but also magmatic nickel. So some examples of external data sets that we're putting into the atlas. So we've got the CSIRO over here, their mafic, ultramafic geochem data set, which for us, there's 20, 30 years of geochem data from CSIRO. So it's sort of a no-brainer to put it in and help fill the gaps, maybe in geochem that we don't already have. And also we've cleaned up this data set a fair bit as well and put it more in line with what you would see if you were open to one of our WACM spreadsheets. So hopefully just making it a bit more accessible. And over here, the same thing, Martin Goals and Steve Barnes' Eastern Goldfields Komatiite Facies map. So again, directly relevant to you guys. An incredible amount of work going into this. So again, no-brainer to put it in to the atlas and just to make everything in the one place and more accessible to explorers. Prospectivity analysis. So as I mentioned, we've just released, I think last week, a couple of weeks ago, our pegmatite-hosted lithium prospectivity map. This report I don't think is out just yet, but it's imminent, so look out for that one. And basically, in a nutshell, what we've done is that we've taken our Mineral System Atlas data sets, we correlate it against known drilling, we then rasterize it, combine it, and turn it into prospectivity maps. So for each of the source, pathway, and trap, we come up with individual maps. We then go about weighting them, and we come up with something like this, a nice combined prospectivity map. So this is for the lithium, and as I said, we're currently working on the nickel one as well, so watch this space. So if anyone would like to go and play with it or have a look, here's the link down the bottom here, or you can just do what I do, and that's Google Mineral System Atlas. But yes, I'd be very keen for feedback, because obviously we've made this and what we think would be useful for you guys, but we're not the ones that are going out there and exploring. So anything that you want to see, anything at all, please come and see me or email me or Paul, and yeah, we'd be happy to have a chat. So thank you.